Welcome back to Auto Technic. Today I'm back on the F355 project. Our cylinder heads are finally back from the machine shop, so we're ready to start working to get this engine put back together, work towards getting it back in the car and back on the road. However, I will give you guys a warning. Today's video is going to be the most in-depth and technical video I've made to date. There is just a lot of items I have planned to cover on the cylinder heads, the engine, and the reassembly process. So I invite you guys to settle in, get comfy, and let's geek out on this F355 together. Okay, so before we just jump in and start looking at the cylinder heads, I wanted to take a minute and cover a little bit more on the engine. Now, I did a real quick high-level overview on the last video when I tore it down. We talked briefly about the configuration, it's a flat plane crankshaft. You know, I quickly highlighted that yes, it's an aluminum block. We got steel liners. The pistons are forged. It's factory studs. So pretty unique for a factory car, especially considering that this was made and developed in '95. But frankly, this technology and configuration Ferrari was doing all the way back essentially since their inception. All of their early V12s and V8s, everything's been aluminum blocks with liners and studs. That's how they've always done it. It's how they still do it. Now, another unique thing about this engine is the fact that it is a dry sump oiling system. However, our oil pumps are installed within the sump of the engine, aka within the oil pan. So you can see we have our lines here for the oiling system that go to the external tank that we have off. That tank actually sits aligned here on this little dowel. There's a rubber grommet and bracket that slide over this dowel and located on the subframe. Then it's actually bolted up onto the body of the car. So the sump is actually pretty low and narrow, close to the ground. And really, I think for the most part, despite the fact it's a flat plane crankshaft, that's all pretty standard. We will come back and I'll show you in a little bit more detail about the flat plane crankshaft because I had several questions on that and we really skimmed over it. But before we do, one other interesting thing to note here is we have our crankshaft coming out of the engine, and these are the drives for each timing belt. Now these drives are gear driven directly to the crankshaft with a gear set that's behind this cover. So we do have a clockwise rotation engine. However, these turn counterclockwise, meaning our timing belts, camshafts, and valve train all turn counterclockwise while the engine is turning clockwise. It's a little bit unique. A lot of Ferrari setups are that way. Once we have everything together and I'm rotating it over, you'll see that configuration, how it is. So it's one thing to keep in mind once we get to the point where we're degreeing in camshafts, because our camshafts are actually spinning backwards to the crankshaft. So one of the most unique things about a 355, and as a matter of fact a 348, is the gearbox or the transaxle. So our engine is a normal longitudinal engine. However, our gearbox is transverse, and I mentioned this in the other videos, but now that we have the heads and the exhaust off, we have a much better viewpoint of it. So you can see back here, this back plate, this is where all of our lay shafts and gear sets basically sit behind this plate, and they're running this way within the transmission. So if we bring you guys around over here, you can see right under here, underneath this axle is the other end of that plate. So you can just envision that all of the gear sets and shafts are running essentially parallel with the drive axles of the car. So it's a very unique setup. You can see that the differential is sitting essentially on top of it. So we have this big pumpkin sitting up here. You can see that's why the axles look like they're kind of coming out on the top end of the transmission here, is because the differential is sitting above the entire gear set. And then we come all the way to the back, and you can see we have our bell housing, which our flywheel is actually back here, our ring gear, you can actually even see our starter, but our flywheel and clutch is all back here. So the way this configuration works is we have a shaft that's connected to the crankshaft that is running all the way through the transmission, all the way back here, and to the flywheel. Now this shaft happens to be hollow, and it has a second shaft on the inside of it that is splined to our clutch that is running back up into the transmission and to a gear set driving our transmission shafts. Then on the output shafts of the transmission, there's another gear set running up to our differential and out to the axles. So this makes servicing the clutch and flywheel extremely easy on these cars. Now, I did mention on my initial video that these flywheels are a dual mass flywheel, so there is basically two moving parts of the flywheel, and it's dampened with springs and some packing grease and sealed with O-rings. That packing grease does break down over time. It can start to leak out, and it can also just get really thin and not be as effective, so you can get some flywheel chatter and rattle back here. That's one thing to keep an eye of. It's very easy to service these clutches even with the engine in the car. So if we have the engine in the car and we need to get this clutch serviced, you would be removing the back bumper, removing the muffler, and popping this flywheel cover off. So a lot easier than conventional setup. So in the car, the muffler is sitting essentially right here, right behind this bell housing. And if we look at the transmission, the overall packaging, if we're considering that the end of the bell housing is here and the transmission is up there, I mean, this transmission is maybe 2 feet long. It's incredibly short, and that's really what allows them to have such a short wheelbase in this car. You can see that it's very short. There's a very low overhang. You can see that we have a very narrow muffler, and the bell housing sitting essentially right there. And that's why they went that configuration. It's the only way they could keep this packaging so small and so tight. Now, the main difference from a 355 to a 348 gearbox is a 348 is a 5-speed, 355 is a 6-speed, although they do share a lot of internal components with one another, and they have the exact same layout. Now, I will say in the successor to the 355, which is a 360, and a 430 is the same way. It's a normal gearbox, essentially, that runs all the way back here, and I'd say that gearbox probably extends about this long. It's an incredibly long gearbox, and the way they overcame the extra length that they had with that configuration was they actually moved the muffler up above the gearbox, so I guess a little bit higher center of gravity, and everything runs up underneath of it. So just this layout and configuration of this gearbox is really one of the most unique things about the 355 and 348. There are a few derivatives of other cars like the Mondial T that share the same setup, but essentially the drivetrains of those are, 80% the same as these cars. Now, I nearly forgot to go over one of the unique things about this particular car, and that's the fact that it's an F1 equipped transmission. So this gearbox itself is a full manual gearbox with our clutch and our manual gear set, and we have right here the F1 system. So if we come around here, there is an electronic hydraulic pump right here. We have our accumulator for the system, and you can see each one of these round solenoids is the valves that controls the system. So we generate hydraulic pressure with our pump and accumulator. They all come down to all of these lines right here. Now, if I bring you guys over, you can see right here is our shift actuator, or the F1 actuator. All of our lines come into that. And right here is where the shift shaft comes out of the transmission. So this actuator is actually pushing and pulling and rotating our shift shaft, selecting all of the gears. And if we come up here, out of our hydraulic block is our feed line all the way down, which goes into our release bearing, which is controlling the clutch. So this entire unit is doing all the gear selection and movement on the transmission and clutch actuation for the shifting, which the driver controls from in the car with these paddles right here. There is also an automatic mode where it runs it. So the driver manually selects the gears. The computer does all the work. Now, the 355 is the first car to come out with this system, and it didn't come out until later in its production run. When the car was first released in '95, it was only equipped with as a 3-pedal car with a manual shifter. So this system was retrofitted in the 355s, and if we even look right here, you can see it has provisions in the oil pan where the shift shaft actually would run through and connect back up to the gearbox. So it's a pretty neat system. This is the very first version. It's a bit primitive. As it evolved through the years, they got a lot better, a lot more advanced, a lot faster shift times. And when you get into the 430 era, it's actually pretty rare that they actually had manual transmissions. And the F1 system went away with the 458 and California when they first moved to the dual clutch gearboxes. They completely different technology and abandoned the F1, and that's also when the manual transmissions completely left the brand. So pretty unique system on this. It's pretty basic, like I said. It's all just bolted on. There's an ECU in the car, a few extra sensors that it's monitoring things. As I mentioned, when the system evolved, that's where they added more sensors, clutch pressure sensors, accelerometers in the cars. The ECU has more capability, so it drives more like what a human could do with the clutch, where this car is still a bit robotic-y. Pretty fun. Some people really love the F1 systems in the cars, and a lot of people prefer not to have them. So it is actually a common swap to remove all of this from the car and convert the cars over to a true stick shift with 3 pedals. Since this was an afterthought to the car where they added it in, meaning you can just remove it, add in all the components that make it a true stick shift, the 3 pedals, the shift linkage, the clutch lines from the master cylinder, and boom, you're in a full stick shift car. However, parts are nearly impossible to find, no longer in production, so parts availability is very hard to find on converting these over to a normal 6-speed or a manual conversion, they call it, even though the gearbox is still a 6-speed and still a manual. F1 system was never available on 348s, only the 355. So that's just one unique thing on this particular car because it's an F1 car. So we got the gearbox covered in a bit more detail. Hopefully it makes sense for you guys. I'm getting in here and you can see this view. You know, it looks pretty clear that this is the in case of the transmission, where when we take it out, if we were to rebuild it, we pop this cover off and the gear sets come out of the side right there. And you can clearly see where the gear sets are sitting down below our final drive from this vantage point. Now, with that being said, we got that covered in enough detail. I wanted to swing back and cover the flat plane crankshaft in a little bit more detail. Now, one of the biggest differences of a flat plane crankshaft is basically the arrangement of the pistons. If you look at it, I mentioned this previously, but the 2 outer pistons are basically traveling on the same, they're synchronized essentially, and the 2 center pistons are also synchronized. And over here on the other bank, it's the same, where the outers are synchronized and travel in the same position as the inners. Although all the pistons on this bank are 90 degrees offset from the movement of the pistons on this bank, therefore the 2 center pistons are at bottom dead center right now, the 2 outer pistons are at top dead center, and everything on this side is at the middle stroke. That's why they're all equal, and that's where this really deviates from a cross-plane crankshaft. I'm going to set some cameras on here. I'm going to label the pistons so we can rotate the engine over. I'll walk you guys through the firing order, and hopefully that will give you a better visual of what's going on, as opposed to our standard domestic V8 with a cross-plane crankshaft that most of us are probably used to. Okay, so I took a quick second and laid out our cylinder numbering on the pistons with some masking tape. And essentially on the Ferrari V8s, the best way to remember it is it runs like a big horseshoe starting from the passenger side of the engine. So it's 1, 2, 3, 4, jump to the back of the driver's side, 5, 6, 7, and 8. Now I think we've visually seen the difference here with this flat plane crankshaft versus what we would see with the heads off on a cross plane crankshaft. But a lot of people still don't understand what is different about it and what the consequences, pros, cons of those differences are. So with our cylinders numbered out, I'm going to be able to go and rotate our engine over. And now that you can see it in motion with the pistons, you can see a radical difference of how the pistons are moving versus a cross-plane crankshaft. Now, in order to really see the true difference of this, I'm going to run you guys through the firing order of the engine. So if we start here on cylinder 1, let's pretend it's on top dead center, and that's on compression. So we're going to start the firing order here on cylinder 1. As we rotate the engine over, the next cylinder of the fire is going to be over here on the other bank. It's cylinder 5. And if we go another 90 degrees, the next cylinder of the fire is going to be over here, cylinder 3. Moving back over to the next one, cylinder 7. So if you're catching a trend here, we're alternating from side to side. The next cylinder of fire is cylinder 4. And once again, cylinder 8. Move it over again. Finally, we're back up here firing on cylinder 2. And the last one of the cycle, cylinder 6. So that's really one of the big differences between a flat plane crankshaft to a cross plane crankshaft. Now with the piston arrangement and firing order on a cross plane crankshaft, at some point you're going to have 2 cylinders on the same bank fire back to back, versus on the flat plane crankshaft, that does not happen. Each firing pulse that we have, it alternates from bank to bank to bank to bank, back and forth, evenly spaced. So that is what contributes to the very smooth, high pitch, kind of high RPM sound that you see out of these Ferrari engines versus a domestic V8, which has that very lopey, rough, rumbly sound. The firing order is what's causing that. Now, specifically on the 355, which actually makes this sound even better, is the fact that this is a the flat plane crankshaft, that the exhaust headers are a 4:2:1 design, and also that they merge into an X pipe for the catalytic converter bypass. That exhaust bypass acts as an X pipe where it merges the exhaust gases from bank to bank together. Since all of our firing pulses on each side are equally spaced amongst one another, they're all equalized with the 4:2:1 header. Everything's essentially like smoother and in line going into the exhaust. Then they merge together in that X pipe, which just really balances the exhaust out. Really gives it a high frequency and really just contributes to the beautiful sound of this engine. Crankshaft, your exhaust pulses are very unevenly spaced in your exhaust from bank to bank. Even on one bank, it's very uneven where you're going to have nothing firing, the two cylinders firing back to back as it jumps back and forth. And that's what gives it that, that rougher American V8 rumble. So two very distinct sounds out of each configuration of crankshaft. Me personally, I love both. They both have their place. I enjoy each one equally, and I don't really have a preference over one or the other. I grew up as a domestic V8 lover and a hot rodder, so that's kind of my soft spot, but I really appreciate the sound these make as well. One important thing to note about this, though, is the pros to this advantage is the exhaust pulses are spaced more evenly, especially if you have an optimized exhaust like this 355, and that really helps out with high RPM horsepower. So these engines make a lot more high RPM horsepower, less horsepower down low, less torque. And one of the big drawbacks to a flat plane crankshaft is vibration. These tend to vibrate quite a bit more, and they're actually displacement limited. You can't build these engines very large because you get so much vibration, they just don't like it, and you have a lot of other issues within the engine. I think the largest flat plane crankshaft engine that I'm aware of probably goes the Ford with the newer Mustang. I think that one, if I remember correctly, is around 5 liters. Forgive me, I'm not a Mustang guy. Correct me if I'm wrong there. I know for Ferrari, our largest V8 that's a flat plane crankshaft is in the 458, and it's 4.5 liters. And the engines after the 458 are all twin turbo, so we dropped our displacement down, and we don't have to worry about it. But I can tell you, even with a 458 and the larger engines compared to the 355, you can start to feel the difference with a little bit more vibration there. Just the downside to it. Now, the pros of a cross-plane crankshaft is you don't have that vibration at lower RPM. They don't make the same high RPM power, but they make a lot of low RPM torque. So really, in all reality, that's a better engine for your trucks and your average car that you're cruising around the street, because that's where you're driving. That's the power band you need. You don't need the high RPM power, and you don't want the vibration. So that's really the big difference why you see this in a car such as a Ferrari, the exotic, why the F1 cars, when they're running V8s or running flat plane crankshafts. That's the advantage to it. That's why they're doing it. And as we rotate it over, you can see the big difference of how everything operates. Now, for those of you that have done a lot of work on a 4-cylinder engine, you'll notice that the piston movement on this is pretty much identical to how a 4-cylinder engine will be. The best way to visualize how this is working is essentially that it is 2 4-cylinder engines married together. So this will be an individual 4-cylinder. This bank's an individual 4-cylinder. It's just 90 degrees off. Now, this particular 355 is not the best example because it runs one simple Motronic system. Since this is a OBD2 car, it runs the Bosch 5.2. But I'd say historically and traditionally, most Ferraris, when they're fuel injected, run 2 of everything, where it's really easy to visualize everything, as in I run 2 engine computers, I'm running 2 airflow meters, I'm running 2 crank sensors, usually 2 cam sensors. It's divided bank to bank. One computer and ECU, all the electronics are running one bank. The other computer and ECU are all running the separate bank. And it really helps to visualize that it's essentially 2 separate engines ran by a single crankshaft. It's that way on most V8s for Ferraris, with exception of the turbo models, and it will start and run on just one ECU as well. With that being said, I think we've covered enough here on the engine. Let's go see what we've all been waiting for, and that's that beautiful 5-valve cylinder head that we're going to get on this engine today. Here's what we came to see, and that's these beautiful 5-valve cylinder heads off this 355. Now, if you recall, these came off and went to the machine shop because during my pre-service inspections on the car, I found that I had low compression on bank 1. I initially thought that was going to be attributed to camshaft timing that was incorrect from bank to bank. My camshaft timing turned out to be correct. I ended up doing a leak down test, and I found high leak down on bank 1 out of the exhaust valves. Ended up consulting that with the customer, and we decided to pull the heads off and have them machined. Now, one thing that's important to note is I only knew that I had high leak down out of the exhaust valves. I mentioned that more than likely was a valve job that was going out. However, I suspected valve guides. I did not present this to the customer just saying we needed valve guides, we need to move forward. It was presented as the only known fact that we had was high leak down. Typically, that's from our exhaust valves from the valve job going out. But from past experience, that does roll in the guides. So I prepped the customer for the worst case scenario, and that would be replacing all of the guides in the cylinder heads with new ones and doing a full valve job, resurface, cleaning, assembly, etc. Now, these heads are the later heads, and they came equipped from the factory with the updated sintered valve guides, so it's not as common to see these wear out as it is with the older bronze guides, although it still does happen. So with that being said, I pull the heads off, I break them down to a bare head, all the valve train stays here, and I send them to a machine shop, which happens to be out of state. They're down in Southern California, and he specializes in Ferrari work. And I let him make the determination of what the cylinder heads need. So I let him measure everything, I let him evaluate the wear, I leave the heads assembled so he can see how they are when they come apart, and he makes a judgment call and gives me recommendations. In this particular case, our intake guides showed minimal wear, and he was comfortable with reusing those. Our exhaust guides did show more wear, as we kind of expected, so we only ended up replacing all of the exhaust guides on both cylinder heads. We were able to retain the factory intake guides, which is going to save the customer on his overall expenses here. Now, if you're looking carefully, you're going to notice that we have some new intake valves in the cylinder heads, and in between both heads, we ended up replacing 8 intake valves. Now, you'll see I have my old valves here, and if you look, they've already been machined. Try to get you guys a good light. So you can see where they've already machined that 45-degree angle in the valve. This is referred to facing the valve. And they do this and then inspect the valves to see if they're suitable for reuse. One very common thing, particularly on the intake, is carbon buildup on the ports. That carbon buildup can actually get trapped in between the valve and the valve seat, and that repeated action of the valve opening and closing on that carbon can actually start to cause a lot of pitting and damage to the face of the valve. These particular valves, the stem wear was fine, so we weren't so worried about that. They did have a fair amount of pitting on them, so they went and faced the valves to remove all of the pitting and get a good face on the valve. And then what happens is they have to come back and measure that margin. So if you can see that small dull line from the shiny part of the valve to the edge, that's referred to as the valve margin. And that plays a role in heat transfer of the valve and how much life is left in the valve. And in the end, our valve margin on these 8 valves, by the time they got all the pitting removed and a clean surface on it, was right on the threshold. It was basically borderline where he really preferred not to reuse those valves. So I went back to the customer with that news, and we decided to replace just the 8 valves that it needed. We went with OEM factory valves back into the locations where these particular valves came out of. We did so for several reasons. We wanted to keep the valve numbering on how they were removed correct, and also for the overall installed height, that keeps it the same. So these heads got all new exhaust guides, 8 new intake valves, and you can see that we had the heads resurfaced. I think they took 6 thou off. And obviously the heads got fully cleaned, taken apart, new valve seals, and reassembled. And when they go back together, again, a 355 is a hydraulic lifter, so it's not as critical, but they make sure that all of our valve heights are set correctly, because the installed height of the valve affects the overall spring rate, so you have to have your shims springed accordingly. And the machine shop gets all that taken care of. So this is how I send the heads to them, and this is how they come back. And I rely on their expertise on getting all of my installed heights for the valve set, the valve job, assessing what needs to be done, and getting these heads back as they are. I've worked with this machine shop for years. They do outstanding work, and I've always been very happy with it. The other thing I guess I didn't mention is they did face the valves, as we saw here, but they do a valve job, which I can't show you here, but I can show you on this primitive head over here. And if we see those lines that are kind of right here, this is our valve seat. Those are your valve angles. So whenever you hear someone talking about a valve job, cutting these angles into the seat is the valve job. The valves just have that simple 45 that I showed you. Now, depending on how many angles are cut in, you hear a 3-angle valve job or a 5-angle valve job. That's just referring to all these different angles. Now, what's a lot of people don't realize is that these angles are extremely critical for the actual performance and airflow of the head, for the air to kind of wrap around this into the cylinder. Not all angles are the same. meaning not all heads want the same angle. So that's very different for each head. Some heads like a 5-angle valve job, some like a 3-angle valve job. That's all very different. So that's something that I let the machinist, again, that's his area of specialty. He does a lot of 355 heads, so I let him focus on that. But when I first suspected that our valve job went out, that is meaning that these angles from the valve opening and closing over all those cycles aren't as sharp and have worn quite a bit. So you're losing valve sealing, and it also affects your airflow. So we went into this expecting to, hey, we're going to have to do those valve angles or a valve job to get that corrected. Now, one thing to keep in mind that when you recut in your valve angles, it sinks the valve a little bit deeper into the head. And if you also think about facing the valve, you're cutting material off the face of the head, which ultimately sinks the valve deeper into the cylinder head, which makes the top of the valve, where the retainer and keepers sit on your valve spring, sit further away from the head, so your springs actually are allowed to sit taller. If you have a car with mechanical lifters, that can affect your lifter clearance, and it also affects your installed spring rate. So you know, it's not as simple as just cutting in your valve job on the head and the valves. You also have to pay attention to the overall height and everything on the top end, because as you remove metal, it's having consequences on the top end of the head. So with any good machine shop, I was given back all the old parts that we removed from the heads. So you can see that I have all of the original intake valves that came out, all of our original guides, even our valve seals. I mean, he even included all the old core plugs that he pulled out of the heads and gave them back with me. But he also did send me a couple extra valve guides here so I can show you guys the difference and really just kind of talk you through the differences of the different guides that were equipped and are available for these 355 heads. So, the early 355 heads came with the factory bronze guides. This right here is a factory 355 bronze guide. Now the advantages of the bronze guides, it's a softer material, so it's much more forgiving on your valve stem wear. However, as we all know, they wear out very quickly, and there is a chronic problem with valve guide failure or premature failure on the early 355s. Now, another advantage of the bronze guide is its ability for heat transfer. Most all the heat from the combustion process actually comes into the exhaust valve. These run a lot hotter than the intake valve, especially considering the intake valve is being cooled with fresh air and fuel. But all of that heat is transferred out of the valve face into the valve seat, and also the valve stem into the guide and into the cylinder head. Bronze is much better at that, so it gets a lot of heat out of the valve. And so that is definitely one perk, not to mention that it's kind of a almost like a self-lubricating metal. So those are some of the pros. The negative is the short lifespan. Now, because of the problem that Ferrari had with the bronze, they went to a sintered guide. So a sinter is like a cast iron or a powdered metal type material. Significantly harder. Much longer lifespan out of the sintered metal guide. However, since it's so hard, it's a lot harder on the valve stem wear. So you're more likely to start seeing higher wear on your valve stems from this guide. This is what guides we replaced into the heads, and this is a bronze manganese valve guide. Now, this is a combination or a special mix of alloys, which actually the manufacturer doesn't really publicize the exact mix of it. It's very proprietary to them. And this is a guide that the machine shop actually had custom made for his needs. So, what's the difference of the bronze manganese? Why are we moving away from what Ferrari updated to? Well, this gives us the advantage of the bronze guide. It's the softer material, it has the self-lubricating properties, and we have the superior heat transfer. However, since this is a bronze manganese combination alloy, it's harder than the factory bronze. Therefore, we kind of, best way to give you an analogy is we get the wear benefits of the sintered guide with all the superior heat transfer properties of a regular bronze guide. So this is basically the best of both worlds on this guide. You can see that it's actually a very nice piece, very high end. And one thing to note, you can see the factory guide, it has this register and shoulder here at the top with a 45 angle on the bottom, meaning the cylinder heads that use the factory bronze guides are different than the heads that use the sintered, because these don't have that shoulder machined into them. So in order to retrofit our head with these bronze manganese guides, the machinist actually machined in a register for that shoulder and got that set in there. You can see up here This is just a bronze manganese and a factory bronze valve guide as well, and what he replaces them to. So you can see the differences of all three guides. In my opinion, this is superior in all the ways. It kind of bridges the gap between the two. I did give the client the option, if he so choose, to replace all of the guides in the cylinder head with the updated bronze manganese. However, he decided not to because just really to save on the expense of it. And one thing that a lot of people don't realize on these 355 heads, because you have 5 valves per cylinder, the setup time and labor and the parts to get everything done, it's quite a bit more machining time and labor to get that done. So we were able to save some money by just only doing the exhaust guides and retaining the factory intake guides. Now, I was mentioning the setup time to do the valve job and valve guides on these cylinder heads. And if you look here on our intake valves, they actually happen to be at different angles. So our 2 outer intake valves in respect to this deck surface, if I show you over here on this head, they're laid back at about 11.8 degrees, and they're actually laid away from each other at about 2 degrees, whereas the center valve is laid back from the deck at a 4-degree angle. Now the exhausts, they're symmetrical all the way down, and they're at about 11.3. So, meaning when he set the head up to do the guide replacement, the machining for the register, and even the valve job, he can set this head up on that angle and run all the way down and get all the exhaust valves done. Quite standard. On the intake side, it's a lot worse than that because he essentially has to set it up 3 times. He has to set it up for all 4 of these valves since they're at an angle away from each other. Then he'll set it up for the other outside valves, and he can do 4. And then he has to come back and set it up for the intake side and the center, since they're all basically running 3 different angles respective to one another. So that's one of the factors that drives the cost up on these heads. But if you look, try to get the camera in there, and if you guys can see how those valves are actually at different angles. So you can see that this valve is much more vertical than these valves, and you're not going to see the 2-degree angle, but these valves are kind of bent like that, so that way they open, imagine, towards the center of the cylinder, and that also gives it room up here so the lifters have separation from one another. If you look carefully, you can see that this center valve, this hole for lifter buckets, pulled back to the outside of the head, and that's what contributes to that different angle. So this one's much more vertical than the 2 outside ones. Also, you'll note that these combustion chambers are incredibly shallow, and this engine with those pistons, factory, these things are running 11-to-1 compression, which is pretty good for back in the era. You know, running that on pump gas and not seeing detonation issues. I guess fun little trivial fact for you guys, the 458 Speciale, that thing is actually running 14-to-1 compression, factory pump gas, but that engine's radically different. It runs factory direct injection, and it runs the Eldor ion system for knock control. So it's not even comparable, but I can tell you that it's a wild difference driving that car on the street with that much engine braking and that much compression. Like I said, the hot rodder and me, I grew up with a hot rodder, and 10-to-1 compression was really a big deal back in the day, and it's mind-blowing that they're getting away with 14-to-1 on a pump gas engine. Anyways, back to the 355 heads. So, some unique things, if you look carefully, our heads are numbered for where our cam caps go, and they're just hand engraved from the factory, and you can see up here that I have all the corresponding marks up there. You can see that I have everything laid out in order, so I don't fully rely on those marks, but I do obviously have the marks on the heads, but the cam caps back on the right location, and the camshafts. Now, speaking of the camshafts, something pretty unique there. If you look down right where this center bolt goes right into the camshaft, you'll notice that we also have holes drilled into all the journal surfaces of the camshaft, and that's because the camshafts are hollow. As you can see by our cam gear bolt, it's sealed with an O-ring. The camshafts, take you back to the cylinder head, are responsible for our oil distribution within the cylinder head. So we can see those 2 plugs right there, and that bottom port, I'll get my hand under it here for you. That bottom port right there is where our pressurized oil comes up into the cylinder heads. Through the machining, it comes into this port up here for the right into the first journal of both camshafts. All that pressurized oil runs through the camshafts, and that's what's pressurizing each one of these journals. Also, that's what's feeding oil up to our lifters as it leaks out. Now, one thing to note, when I pulled the valve cover off this engine, it had sat for a very long time, so all my oil actually leaked out and drained back into the engine. But it was frequent when we were servicing these cars at the dealership. I was usually driving the car the same day I pulled it out and got it apart, and these trays are usually completely full of oil. And actually, if they are, when you're doing the service, that oil slowly leaks down and gets on your exhaust manifolds and will create a massive smoke show when you first start the car back up. But it is standard to have these basically, when your lifters are in or cams are in, just big troughs of oil. You can see that it has small little holes there to drain it back down to where, think of it as this head. It looks like a simple casting, right? But there's two tiers to it, where there's a whole bottom tier underneath where our valve guides and springs are. I got my fingers down there on the valve springs right now. But up here it has this upper tray that holds all that oil as it drains down. And then we'll flip this head over. All of our oil drains out this port to those tubes that runs down back into the block. Now these are removable because that's where our head nuts go. So it's one of those things that I think it's so simple but also kind of sophisticated. And if you really compare what they have crammed into these heads, I mean, we're talking 40 valves and 2 camshafts and some absolutely outstanding intake ports into such a small package. I mean, sure, they got a goofy valve cover gasket setup and there's some goofiness about the head, but there is a lot crammed in here in such a small package. I mean, if I compare the size of one of these heads to this old small block Chevy head, these things only hold 8 valves and valve springs, to whereas these heads have to hold 20 valves, 2 camshafts, and all the valve springs, and yet they're still so much smaller. So I find it quite interesting because in some ways these castings are incredibly simple, but in other ways they're incredibly complex. In reality, I'm going to take a better oiling system, a better intake port design with an inferior head bolt design over an easy head bolt design and an inferior port system any day of the week. Now, I will take a second and talk about the valve covers because I've had a lot of people reach out about that on how they seal up, and it's just, you know, wild to them to see it that way. I will say that that's pretty much how all the valve covers Ferrari did sealed up from essentially the inception of the brand all the way up into the early 2000s. But my thinking on that, or my train of thought, is essentially they machine the head. It's got a simple flat surface up here for where the valve cover is. They put the cam caps on and they run all their machine tooling straight through the head all the way through the size of their cam journals here. Well, you need access for that, so they just leave a simple end of the head, and then that's where they use the cover plates or that round plug to cover all this up. And that's why we have this goofy transition for the valve cover gasket. They could have made a more complex plate, but then you're machining the plate to the head, or it's a more complex casting that basically have provisions for the machining tools to go through there. And one thing I want to keep in mind is a lot of people have made comments or references to these cylinder heads and the way they're designed and cast in reference to other manufacturers that say, for example, Toyota. In 1999, Toyota probably built upwards of 5.5 million cars worldwide, and Ferrari built just under 4,000. So the investment that they're going to spend on casting and tooling and machining to produce these engines, it's significantly smaller. So one thing to keep in mind, Ferrari is a very large automotive brand. However, they are an incredibly small and low volume manufacturer. So there is some differences on them. They do look a little homemade in some aspects, but a lot of people do compare Ferrari to the other brands because it's such a big, reputable name. I mean, the brand image is just huge, but as a company and a manufacturing company, they are incredibly small. A lot of people don't realize just how small this company is. They're getting bigger now versus they were in the 90s, but given the resources and size of the company, the era, and what they were building, I find it pretty impressive of what they were able to do. All right, guys, before we get back to this 355, I want you guys to do a favor for me. I want to do a bit of an experiment. I want you guys to jump in the comments and light that section up. Jump in there with any questions or comments you have. Also, what I'd like to see in that comment section, I want to know where you guys are from. So drop your city, your state, or your country, or where you're viewing this video from. I think it's going to be a lot of fun for all of us to see where all the viewers are from. As for myself, here at Auto Technic, I'm located in the Seattle, Washington area, so the Great Pacific Northwest. I want to know where you guys are viewing the video from. With that, let's get back to the 355. All right, I think we've covered it with talking about the heads and the engine, and we can start the work to get this put back together. And well, first thing I need to take care of is getting some oil back in these cylinder walls. You can see that I have cleaned everything, all the carbon off of the top of the pistons, and also from cleaning the surface of the heads. And well, in the process of doing so, I used some brake cleaner and some acetone, and all of my cylinder walls are actually pretty dry now. And on our initial fire up of the engine, I don't want to have them that dry. I want some oil in there. So I'm just using some special sauce I have. Not really special sauce, it's actually just a combination of ATF and Marvel Mystery Oil mixed 50-50. It's kind of my favorite thing to lube cylinder walls with. I use it when I'm building engines. The ATF really helps because ATF is very high in detergents, and meaning it helps clean things. So if you have a block that's back from the machine shop, let's say you had it bored, take a clean white paper towel, cover it in ATF, and if you wipe it in your bores, you'll probably be surprised on just how much metal and black grime you'll actually pull out of there. It kind of makes sense if you're ever working on an automatic transmission and all your tools are real dirty, or your hands, and by the time you're done everything's clean. That's from all the detergents in that ATF. So I use that just to get a little bit in here, and I don't want to have everything soaked, so to speak. I just want a little bit of oil in there, and any extra I'm going to take off. But we just don't want to have the car fire up with dry cylinders. So we got some oil in there. Run it in. And work it around. And obviously I'm going to have to come back and get all the oil off the top of the deck. Those two could use just a little more. All right, and then we're going to just rotate this over, and we're looking for top dead center of cylinder 1. And there's a little bit of dwell there, right about there. Now, there is no marks for our crankshaft for top dead center. I'm just visualizing where it's right at top dead center. But when we install our cams and everything, we want the piston top dead cylinder number 1 so we don't have any interference issues, and also to enable proper timing. So now that we have it on top dead center, our cylinders are lubed. I'm just going to use some acetone and a rag and go over our deck surface one more time, just to be sure that none of that oil and ATF got on our deck surface where it's going to potentially get on our head gasket. And you'll notice that I've already gone through and prepped my deck and got everything cleaned off. So I'm a bit old school in that regard. I do it the old and hard way, meaning I don't use any power tools, so I'm not using a die grinder with one of those nylon roll-lock wheels or even the Scotch-Brite. I think a lot of people jump to a Scotch-Brite on a die grinder or even these nylon wheels, and I do not use either of those to get the gaskets off. Those are too aggressive, too abrasive, remove material, leave a lot of tooling marks, and I do not use them at all. So I really want to do the minimum amount of, not damage, but affecting the deck surface as possible. So I actually just, a lot of hand labor, use a flat razor blade, scrape off as much of the gasket as I can. Then I come back with some WD-40 and a maroon Scotch-Brite and just scrub. And I scrub all the carbon off, all the old gasket off. Sometimes if you got some stubborn areas, some brake clean or acetone really helps out. Clean the carbon off the pistons. That's just my OCD there. I just couldn't stand to put the cylinder head back on with the dirty pistons, but there's really nothing to be gained by doing so. But that is just my technique. I just sit down, grab a stool, maybe turn on some music, and scrub away. It's a bit tedious, but it comes out pretty good. So we're all clean here, and I think we should be good. Okay, so we have our cylinder walls lubed, ready to go. The deck surface is cleaned. I've gone and put assembly lube on the threads of all my studs. All my hardware is up here. It's lubed and ready to go as well. I just pulled the gaskets out of the package, and a bit of a curveball thrown at me. This may be just due to my poor memory, honestly. Tell you the truth, it's been several years since I last had a cylinder head off of a 355, and this is something that I didn't recall. But is what we're facing with is I have our standard gasket, and it's just your typical graphite gasket that you'd see on most cars of this era. We don't need like a more modern MLS on this because the cylinder pressure on a naturally aspirated engine is pretty low. So what caught me by surprise on this gasket is you see it has a pretty shiny finish all the way around. Bring you guys up gasket too and show you. So it has a nice sheen all the way around. So when it was in the packaging, I could see obviously it has that red impregnated silicone bead around that goes around all my coolant and oil passages around each stud, and that's very typical. But I don't recall this other coating that's covering the entire gasket, including the firing rings. And this coating feels like a really soft, I'd say it's rubbery. It's not sticky, but it is very impressionable, and it has very high grip, like if I'm trying to rub my hand and pull it across it. And the best way to describe it is it almost feels like a glue. Like it feels like if I'm going to compress this and heat it up, it's going to glue itself to the block is what it feels like. Now, the reason why this was unexpected is I don't recall having that coating on there on any other Ferrari head gasket. This is a factory Ferrari head gasket. And I will say that specifically in the 355 workshop manual, it gives us very little information on installing a cylinder head, but it does go out of the way to tell us to install it with no coatings or nothing on it. Just install the gasket as is. Now I'm going to jump back to another car I had, or I should even jump back before that. Previously, whenever I do head gaskets on Ferraris and any other model, I do put a little bit of sealant around any critical passage, meaning for coolant or oil, just as extra insurance. You know, the belt and suspenders method. Why just use a belt to hold your pants up when you can use a belt and suspenders? That train of thought. So the sealant that I use is 3-bond 1211. This stuff is very viscous. It's very thin, and it goes on real thin, real smooth, and squeezes out really nicely, and that's specifically why I use it for this, and I've always had good results with that. Now we're going to fast forward to back when I was at the dealership, and I'm doing a rebuild on an F40. And I got to think to myself, like, man, this is an F40. In my opinion, it's the best car that's ever been built, the best automobile. And I'm like, I'm going to do this by the book. I want to make it perfect. I'm going to follow the manual to a T. I'm going to put these gaskets on dry. And I deviated from my normal procedure and didn't use that sealant. Well, got the heads on, got all my cam timing done, belts on, the engine back together, the engine back onto the gearbox, the whole assembly back into the car. Guess what happened once I put coolant into that car? Sure enough, coolant dripping out of the front of the head from the block down onto the ground. Had a coolant leak. Absolutely devastating. Had to pull the engine back out, pull the heads back off, completely lost all my cam timing. Put on new gaskets, the second time with sealer, put it all back together, retimed the cams, back into the car, everything was good at that point. So with that, it was kind of like a lesson. I deviated and it bit me from my normal way. However, with this coating that we have on these gaskets, I think that sealant that I have is so slick, it's going to impede this coating that's on there. I'm struggling to find the best way to describe this coating, but it definitely is on there for a reason, and I do feel that, like I said, once this is torqued down and compressed, it's going to basically glue the head to the block together and seal up really well. So, with that being said, we are going to install these dry without that sealant. And on these gaskets, it's pretty basic. It just says alto or high, which is the top side. You can see we have our provisions for oil drains and our 2 dowels for the 2 studs. So, yeah, would really have to work hard at this to get it installed backwards. And we're just going to slide this on. And I'm trying not to touch that coating as much as I can because I have noticed that it leaves fingerprint marks in it when I do so. Slide it on just like so. And we're ready for the head. So much like the block, I went and cleaned the surface of the head with some acetone. It is dry and ready to go on. So we'll see if we can't gently set this head on and see if I can't hold it in a manner where I can get a good visual on my studs. Get that lined up. Slide it down. Now, I don't want to push the head all the way down to the block surface because I need it lifted up a little bit so I can actually fit all my washers and nuts in here. Otherwise, they kind of hit the top of the head and I don't have enough room. So I'm going to go through and get all my hardware started on the studs. See if I can't get that in there. There we go. Before I push the head down so I don't have any clearance issues. Got our top row done. Grab our washers here for the bottom row. So speaking of that same F40 where that head gasket bit me, if you actually notice on the very end screen of my videos, that end card where I'm sitting in the engine bay of a car, that happens to be that same F40, which that car actually is one of the best stories of repair orders, problems I had with a car, and just overall jobs that I've done in my entire career up to this point. So maybe someday I'll elaborate on that job. It's pretty fun story, and it really helps that the F40 is my favorite car of all time. Fighting to get these guys in here. Got that one on quickly. There we go. Got them all started. See if I can't run them in as far as I can. Now I'm just going to use my wrenches to run the head down. That one's not. And we'll use the special tool to get it torqued. I just prefer these wrenches because, as you can see, the special tool here, it's a bit more cumbersome to use. These are a little bit quicker up until the point to where we need to actually start torquing the head. As you can see, we don't have a lot of bite available to us. Push the head down. There we go. That's going pretty good. Pulling the head down. Just got a little snug there. So you can see that I really just kind of have to work these down by hand, use a little bit with the wrench, and I'm just trying to get the head down the snug. And then we'll worry about using the special tool and torquing them in order. Now the reason why I use these wrenches a lot, like I kind of mentioned, the special tool is cumbersome to get in there and you don't have a lot of room for access, so I have these wrenches that I made. Now I ended up making these wrenches. One's a 6-point, one's a 12-point. This one actually happens to be a 9/16, that 9/16 6-point that fits really tightly on the heads. You can see I modified it to kind of clear the casting. I ended up making this tool because in between the heads being on for a long time, the head studs being exposed to outside elements, meaning if the guy pressure washes his engine bay a lot of water gets in there, and the heat cycles, the breakaway torque on these head studs is actually far greater than the assembly torque. And with the factory tool, it tends to snap this shaft if you use this to break the heads loose. And I got tired of dealing with it, so I ended up making these wrenches and modifying it because these are easily, I mean, they're cheap. If I break it, I don't really care. They get it on and off. So since I have these, I find it easier to use them. Although this particular tool is a Hill Engineering one, so I'm not sure if this arm is much stronger than factory. But, you know, old habits die hard. I'll just keep using what I know works. I don't know if I would go through the trouble of modifying wrenches like this just to do this job. If anyone's doing this job, you're probably buying a special tool, that wrench, to get this done, and I just would use that. Like I said, I'm just using what I have because habit, and I have it. I know it works, and really no other reason than that. See, that's the problem. It's so tight with the head nuts not threaded down that I can't slip the box into the wrench in there. So I have to spin that nut down. There we go. And this 9/16 one fits a little better in there, but it's a struggle because it's a 6-point, not a 12-point. So I'm limited on my angles. All right. I think we could finish them off here. Just get them snugged down. You can see you don't have much of a swing on this. They get them tight, so it takes several bites. Alright, so now we're going to run through and do our first pass on actually torquing the heads down. There is something I want to mention, and that's with this special tool that we will be using on our 1/2-inch torque wrench. Now, theoretically, this shouldn't matter on where I put the tool on the torque wrench, because where we're applying the torque here is essentially center line with the torque that's being applied to the wrench, even though it levers out. However, this is something that I learned once I actually moved away from automotive and got in the aerospace industry, and it makes sense, but let's say if I were to just have this tool, the socket attaches right here and runs down and out. If I do this, I'm actually going to be applying more torque to the nut than I would be where the torque wrench is calibrated here. And if it was the other way around, I'm going to be applying less torque. Now, there is mathematical equations that you can do to take your distance that you're changing your lever point to your torque wrench and your applied torque, and then you can do that math so that way you're applying the right torque to the fastener. But all of that isn't really that relevant, because if you take your arm and run it 90 degrees to your torque wrench like this, you'll have the correct torque. And that's actually something I never knew. I did know that obviously if you change your location, if you're using like a crow's foot or a dog bone, you're going to be changing your torque setting. I didn't know that if you just run it 90 degrees, even if it's stuck out like so, it's not going to affect it. So it needs to be 90 degrees to your torque wrench. Like I said, took 20 years in the automotive industry, never knew that. Went to aerospace, I learned that. I watch those guys assemble those engines every day, and that's pretty much a standard 101 for them. So a little bit of that knowledge comes around to help me out here. And I will mention that in the factory workshop manual for this 355 that it does actually call out to keep this tool 90 degrees to your torque wrench. Doesn't tell you why, but using what I just explained to you, now we know why. So we're going to run this down, and the first round is 60 Newton meters on all the bolts. And it's a standard pattern starting from the inside and working our way out. So get this on there. Make sure we're 90 degrees. So you can see it takes several bites to get our initial torque here. Close. There we go. Move one out. And I'm trying my best not to have my hand on the end of the torque wrench when I'm torquing, so I'm not affecting the applied torque to our fastener. And I'm also squeezing the wrench and the tool, trying to prevent them from moving when I take it off and put it back on, just so this goes a little quicker. Another thing to be careful of is if you run this special tool over, see right there, it's actually hitting the casting of the intake port. So I get reef on this and it's going to hit my 60 newton meters of torque, but I'm actually not applying the torque to the fastener. I'm just wedging the head of the tool in there. So you got to be very mindful when you're torquing these down where your tool is and they're not hitting. And should be the last one. All right, now they're all on their 60 newton meter initial torque. I'm going to go back around, hit them all one more time just to be sure. You know, double check to make sure I wasn't pressing up on the intake port like I was talking about. And then we'll come back around for the final torque. All right, so it's torqued on to the initial round. Now this part is where it gets pretty tricky because after the 60 newton meters, we need to run each one of these nuts 90 degrees. Now, if you notice with our tooling, we don't have enough room for a 90-degree sweep without taking multiple bites. The old school way of doing this, and the way the manual shows it, is you'd use a separate angle meter that you would apply to your, on top of this special tool, clamp onto the head, and you would have to basically count out how many degrees you've rotated the nut with each bite that you use of the special tool. However, it's where the digital torque wrenches come into play. We can set this for 90 degrees and it will take into account each time I retake a bite on my fastener, and it makes it super easy to get these torqued to spec with the 90 degrees. It saves a lot of hassle. I couldn't imagine doing it without this, so big advantage with a new modern torque wrench. So we're just gonna set this up for our degrees. All right, so we're set for 90 degrees. We'll get our tool back on and do our final torque with 90 degrees on each fastener. See, I only got 53 degrees on that first bite. Well, that reset on me, that's not great. It said 53, 90, so I need 37 more degrees. There we go. So, what happened there is I couldn't get the torque wrench reset on my fastener before it zeroed back out on me. So I just had to use some math on how many degrees I got out of it. So we're zeroed back up. See if I can't get a better... Nope, zeroed back up. We got 21 degrees. 50. 85, whew. 90, whew. So at our 90 degrees, this is putting about 95 newton meters of total torque on our fastener. Whew. Whew. Last one. Here we go. Whew, a bit of a workout. All right, before we install the right-hand head, I wanted to take a minute and talk about the head studs. The first thing, from my experience, it's highly unusual that these are a torque to yield stud, meaning we took them to 60 newton meters first and then went an extra 90 degrees on them, which usually when you have a bolt or a fastener that you're torquing to a certain spec, as in resistance of the torque wrench, the 60 newton meters to start with, and then going a degree, I always refer to those as a torque to yield bolt, where you're technically putting some stretch into the bolt. And generally speaking, from my experience, you're to replace those bolts every time you stretch them. From my experience, usually when something has studs, they're not torque to yield, it's usually a bolt, and usually studs are just a standard torque to a spec and you're good to go. I never encountered a torque to yield stud until I started working at Ferrari. Now, for the 355 here, if we reference our factory service manual, or even there is quite a bit of different information in the owner's manual to service manual, it says nothing about the replacement of the studs when we go to tighten them. It doesn't mention it, just doesn't really exist. And that's pretty typical through the brand. So we can reference some of the other workshop manuals of cars around it and use that as a baseline or reference of what we're doing to the studs. And really, off the top of my memory, I don't think it's all the way up until the twin turbo engines, like the engine that's in the 488 F8 California T, those engines, where they actually start talking about replacing the head studs in the workshop manual. Now, those studs are torque to yield just like these ones are, and believe it or not, Ferrari says they can be torqued or stretched 3 times. So we have our initial install from the factory, and then theoretically there's 2 more times that they can be tightened out in the field for service, and then they should be replaced. Now, some of you might be thinking, let's just jump to it and replace the studs. Well, we have the initial expense of replacing all these studs on these engines, and that's one deterrent not to do that. Also, these studs are quite a bit different. You can see here that there's maybe 2.5 inches of that stud sticking out. As a matter of fact, this right here is a stud out of a 355. See, we're only seeing the top half of this stud, where you can see that it actually gets quite a bit larger and then runs down. And it's actually a really great design performance-wise, because this stud isn't threaded in and pulling on the deck of the block. It's actually threaded in and pulling down near the main webbing where your mains are. So there's a lot less distortion to the block, a lot more strength, and it's actually a really great design. I don't know they're thinking of why they neck it down where it comes up through the deck, and you can actually see that there's a recess there where the studs are. This is important to talk about because we have a couple factors here. One, all of our studs are on the outside of the head. I mentioned it earlier. If you have an owner that pressure washes the car and gets a lot of water up in here, that water can leak down, get in there, and really affect these studs since they're effectively on the outside of the engine. Also, through normal heat cycles and driving the car, condensation can get in there, and they can start to get a little corroded, like you can see on this one, where it's not affecting the strength of the stud, but it affects how easy these studs are to remove. Now, I can tell you that the first time I ever went to pull a set of studs out on these engines, I was completely shocked at the amount of work and effort it took to get them out. I figured I could just double nut the top of them and a little bit of effort and break them free. You're lucky if that happens. Usually, you got multiple sets of vice grips on here. You're heating the block with everything you have. You got a couple guys on it with cheater bars, breaker bars, and double nutted. You effectively completely destroy the studs on the way out. However, I actually have a really good example of how hard these studs are to get out that happened on another 355. So when we're back at the dealership, we had another technician that was doing a set of heads, getting them off, getting them sent to the machine shop, and they did happen to sell that customer a set of head studs. So while the heads were at the machine shop, he went through and started the procedure of removing all the head studs from the block, and he actually, when he got to the last one, of course, it's always the last one, I think it was this one right here, but possibly on bank 2, but it was an upper stud. I think it was the second in. It actually broke on him. It snapped right off, and it had about a 1/2 inch of head stud sticking out of the block. Just sheared it clean off. And I can tell you that was a real moment of reckoning, because we essentially had the engine in this exact configuration right here, and you're kind of posed with a big problem on what to do. Now, when this occurred, at that time I was the shop foreman, so I started talking to the machinist that had our cylinder heads, which happens to be the same machine shop that I used for these heads. And we kind of came up with a game plan, because I didn't want to have to pull the engine out of the car, disassemble the engine, and send it to a machine shop to get the rest of that stud out. That would have drove the cost up of that repair for the client significantly. And I really wanted to see if we could find a workaround, but we were limited with your basic hand tools at the dealership. So after working with the machine shop, we came up with a theory and a method of how we were going to try to get this broken stud out. What we ended up doing is I ended up filing the stud down flat, giving it a perfect 90-degree stud in relationship to the block. The machinist actually went through and machined a standoff that sat directly on the block and had a perfectly machined hole in it. So this standoff slid exactly over the diameter of the stud. So there was a lot of coordinating back and forth where I was giving him dimensions, and tolerances for what we had so he could machine the parts. So we had that standoff up on the stud, and we were using that essentially as a pilot, and I was able to go and drill a hole down through the center of the stud. We initially started with a small pilot hole, drill all the way down. We had basically different plans in place for this, basically best case scenario and worst case scenario. We tried using some easy outs and extractors. We kind of knew they wouldn't work, which they didn't, and we didn't want to break one of those off in the stud, so I ended up drilling the stud out and progressively, so there was not much material left there. And then we once again used an easy out, tried to run it down, couldn't get the stud out. At that point, I basically had the stud up to here and the hole drilled all the way down where it was a small shell. So we actually ended up drilling the hole down and basically removing all of this metal. So all we had was this bottom threaded section left in, a couple inches down in the deck. And we had a hole drilled the center of it, and we had the special tools that he built that I could get the easy out down in there and just try to remove the threaded section. And again, there was no way. I was going to snap that easy out in there, and there was no way to pull it off. So we went with our absolute, basically last resort plan, where I drilled the rest of the stud all the way out and all the threads out of there. Took a tap, tapped the hole all the way back down. We ran some helicoils down in the bottom of it, and we were able to basically drill out the entire stud and install the new stud. Now, I say this as in, it's a quick little story, but it was a massive save. His tooling and fixtures that he made were amazing because it drilled the stud dead nuts down the center. I didn't get into the block where I didn't want to. I can tell you that I spent 2 days drilling this stud out. A significant amount of time going slow progressively, but the fact that I was able to work with him, he was able to make the tooling, and it worked as planned. In the end, we ended up just drilling the entire stud out of the block, tapping new holes and helicoiling it. Once it was all done with the new stud installed, you can never tell that there was a difference. The only way you could ever tell that there was a difference is it was threaded from the top of the hole to the bottom to where the helicoils are, which from the factory they weren't. So that one was a really great example on top of all my previous experiences of removing studs that now it's kind of a last case resort for me. I mentioned it earlier that this is naturally aspirated, so there's not a lot of cylinder pressure in the engine as opposed to a forced induction car that's twin turboed or a supercharger. So meaning our cylinder pressure is not as much, and the clamping force that we need on the head to the block isn't as great as you need in a forced induction engine. So I don't stress about the head studs as much, but if you have something like the newer twin turbo cars or the older F40 where it is forced induction, it is something where maybe I would talk to the client a little bit more about on the studs, give them the option of what we want to do, kind of give them, some insight to my experiences of the difficulties that I've had on getting the studs in and out, and kind of help guide them, but ultimately let them choose what is best for them if they know the pros, cons, what problems we might encounter. So it's just a fun little story. It's pretty relevant to what we're doing here. It was one of my better saves I've ever had in the career. I wish I could take more credit for it, but I really can't. I owe all the credit to that one to the machine shop for thinking up the plan for that tooling, coming up with it, machining it, and really just working with me to come up with the ultimate solution. I really can't say enough about the machine shop that I use on the work that he does to the cylinder heads and the work that he does to me. Unfortunately, he is pretty private, so meaning this gentleman does not advertise, he generally doesn't work with the general public, and he doesn't really want his name or information passed around. I think most people that are within the Ferrari community probably know who he is, and he does outstanding work, and I don't blame him. He's got a great business model. He's got plenty of work, doesn't have to advertise for it, and is pretty guarded on his information. So I wish I could give him more credit so you guys knew, but he wants to stay private and remain unspoken of. And when we were doing the heads, I even asked him on this car. I knew the answer was going to be no, but I said, hey, do you want me to mention who you are and give you some acknowledgement? And he said, nope, I'd rather not. So anyways, that's that story. And now that we have that out of the way, it's time to throw this other gasket on, start working to get this other cylinder head installed and torqued. All right, our initial 60's done across the board. So we're going to go back around and be sure that they're all hit at 60 Newton meters before we move into our final angle torque. Doing this just to be sure that I did not accidentally overlook one, and also to be sure that after it rests for a minute that we're still at our 60 Newton meters. And they're all moving just about the same amount, which is fine. That one moved a little more, but that was the first one we torqued. All right. Reconfigure our torque wrench to do our degrees. So 90 degrees more on each one and we'll be set. 91 Newton meters. So we're about 91, 95 Newton meters on our final torque with our 90 degrees we're doing here. So this 90 degrees is essentially giving us an extra 30 Newton meters. 74, almost there. This one's probably the worst because of the hose. There we go. Got it. Should be the last one. 90 degrees. Got them. Whew. Now we'll take a minute and come back and clean up all of our assembly lube that we got all over the head. And I think we're ready for the next steps. So we're back out here, day 2, and I'm right now getting some lube in the lifter bores and right on top of the valve stem, so that way we can start getting these lifters in and this valve train assembled. I don't want to be, overly greedy with how much lube I ram in there, but I want to make sure everything's coated real well, especially since everything's so dry now, and make sure it has all the lubrication that it needs before the oil gets up there. So I will crank the car over with the fuel pump fuse removed before we fire it back up, just to help get some oil pressure and oil flow and volume up into the valve train since everything's so dry. But this lube is going to help out, for the few revolutions it's going to take before we actually get the oil up in there. Now, this lube that I'm using is just Redline engine assembly lube. It is my favorite lube that I like to use. It's a little bit pricey, but I've had really good results with it. It breaks down really well and doesn't plug up filters or anything, so it's kind of my go-to. It's always treated me well. And I'm using just a little acid brush to work it in there. And one thing I did do before I use the acid brush is I actually kind of just run my fingers down the tip of it and see if I can pull out any loose strands or hairs that are on it, so that way I can ensure that none of them are going to come off while I'm applying the lube and actually get stuck on the head. Now, you can see that I'm getting a lot of it on the retainer of the valve, which doesn't really need any lube on there. It's only the dead center of the valve stem and the outside wall for where the lifters are going to ride. But there's really just no way I'm going to get all this lube in there and pinpoint it. So I'm just kind of coating everything and trying to work it down the best I can. I think that'll work. So for the lifters, I did number them before I pulled them out, and I labeled them on which bank they came out of, if they're intake and exhaust, and then I numbered them from basically 1, 2, 3, 4, 5, just all the way back to the row, and I set them on the cardboard exactly how they came out. Now, technically on the hydraulic lifters, we could just put them in any cylinder where we want, but anytime I have an item, especially if it's metal on metal, where the lifter is riding on the cam lobe, it is absolutely my preference to put them back in the exact cylinders they came from. So one of the things that I did is when I marked the lifters, I actually just used a little bit of a Sharpie, and I wiped the top of the lifters off before I removed them. I marked them with a Sharpie, and I set them on my bench, and they just wait for reassembly. I do so because once it comes time for reassembly, I can just take a nice little shop rag, and I just wipe all the excess oil off the lifter, wipe the top of the lifter, and all the Sharpie comes off, and the lifter is ready to go back into the engine, right, just like that. So I'll grab this next lifter and I'll show you guys my marks here. So you can see that this is marked for bank 2, the second lifter, and it's on the intake side. So with those Sharpie marks, you'll see that it just takes super quick wipe and they're off. So it's a pretty easy way to mark it. You just want to be careful with your lifters that you don't accidentally wipe your markings off. But you know, it's a down and dirty, easy and simple method to have them all marked, so that way I can get them all back in the exact locations where they originally were, so they'll be riding on the camshaft in the same manner. So with that, I'm going to work to get the rest of the lifters installed, and once we get to the camshafts, I have a couple more things that I want to show you and highlight, and then I'll walk you guys through some of the steps and intricacies of getting the camshafts installed in the engine. And all of our intakes are done. Moving on to our exhaust. All right, lifters are in. Time for a little bit more lube on the cam journals and the tops of the lifters. So again, we're not going to be crazy. Get in here. This is like a little indexing groove right here for the camshafts. So we definitely want to get that. And get our journals. Now if we put too much in here where the cam's going to go, it's all just going to squeeze out and we're just wasting our lube. And you might notice how tiny on the intake side these journals are in between those two lifters. And it may seem a bit counterintuitive that there's not much material there to really, you know, give the cam the ride on, but you have to keep in mind that all the valves and valve springs are pushing up on the cam. So all the load of the cam is actually on these cam caps and on the top side, not so much on the bottom. And that's how they got away with such a small journal right there. And really they had to do that because they wanted to fit so many valves in there. There's just not enough room for a bigger journal. And you can see on the exhaust side where we have just 2 valves, there's a standard size journal. This intake side wasn't, you know, it's just kind of the side effect of having 5 valves up here. Now when we were going over the cylinder heads, I did talk about how there's these troughs here, which you can see with the lifters in, with the oil drain hole. And I talked about how the oil comes through the camshaft and sits in this trough and lubricates the lifter. What I forgot to mention, there is a direct passage that feeds pressurized oil directly to the lifters inside the lifter bore. So up here, this oil is just kind of a secondary measure for oil to keep a big bath of oil while they're sitting on the lifters. You can see the drain holes are up here on the top for the intake side. So the way that the oil is coming through the camshaft to the lifters is supplemental oil supply. It is not the main oil supply. Now that everything is in, I'm going to see if I can get some lube around the outside of the lifter body where it's sticking up above the head. And I think we'll be good to go once I get all these. All right, we have everything lubed and we're ready to accept the camshafts. Now, before we just jump right into installing the camshafts, we kind of need to cover how we know which position to install them in. So on the disassembly of the engine, I mentioned that there's no timing marks for the engine on where the cams go and versus the crankshaft. Well, there is some generic basic timing marks on the cam caps that we align our camshafts to. So let me grab those and get them set up. I'll drop you guys in here and I'll show you what I'm talking about. All right, so you can see that I've set our forward cam caps in position for both the intake and exhaust cam. Just like the lifters, I had these marked in the corresponding location where they go because they are doweled to the head and machined to the head. So the bore is machined. These are location, and if I pop this off, direction specific. So you can put them on backwards, but then It's not a precise circle because your machining's off if you do that. So that's why I'm very careful and methodical in how I disassemble them. You can see carefully here, it's also hand engraved with a number 7. And if you look closely right there on the head, you can see that it has a number 7 engraved into it. So they all are numbered also, but I will tell you that all of the engraving is done by hand. Sometimes it's really tough to see. Sometimes the 6s look like 9s. It's kind of hard to decipher. You can see that everything on this side, they're all upside down. So I use that as a backup, but I also just be sure that when I take them off, I have them in the right orientation. I can use the numbers as backup, make sure everything's back the way it needs to be. I will say sometimes on some of the cars where you need to remove the camshafts during the timing belt service, say like a 348, I've found that these caps are actually installed, 1 or 2 of them is installed backwards. So if you have to have these off, be very methodical, pay attention to what you're doing. But on the front ones here is what I want to show you is we have our grooves in the front of these cam caps. So these grooves have a corresponding notch over here on the front of our camshaft right there. You can see that notch. So when we assemble these cams, we need to line this notch up to our groove here on the camshaft right here on the front. However, there is kind of one little trick here, or one thing to be cautious of. So I'm going to need to set you guys down because I need both hands, and I'm going to show you exactly what I'm talking about. All right, so we have our intake camshaft, and we'll spin it so our mark is right here, right where my thumb is. And I'll show you what has gotten me bitten really bad in the past. So if you see here, this is a perfect example. Here's my mark in the upward position where it's going to need to fit on that cam cap. And I don't know if you guys can tell, but this camshaft is very far from fitting. Mainly these lobes right here are on cylinder 7 are pushing all the way down on the lifter, so that's kicking the entire camshaft up. Back here at the back, we're pretty good because our lobes are off the lifters. And obviously up here, they're off the lifters for cylinder 8, but it wants the rock. So why am I talking about these lobes holding this camshaft up and in? Well, all my experience before I worked at Ferrari was with BMW, and they also had hollow camshafts, and they basically instilled the fear of godliness on breaking the camshafts. They actually gave the workshops a special fixture that bolted to the head, would push down on the camshaft on certain areas, that compress the lifters and push the camshaft in evenly, let you get your cam caps on, and you don't have to worry about it. Well, then fast forward years later, I'm at Ferrari, and I have that ingrained in my head, and I'm doing timing belts on a 575. And I can tell you, for one, it was, I think this may have been the first 575 that I ever did timing belts on. I had done them on a 550, so I inadvertently pulled the camshafts out to replace the front cam seals, thinking it was the same as a 550. On a 550, in order to get these cam plates out, you have to remove the camshaft from the head, slide the plates all the way off the back of the camshaft. On a 575, you can just slide them off the front. You don't have to do so. So I already made a mistake already. I was already pulling the camshafts out, didn't need to. Lesson learned. Anyways, as I was putting the camshaft in, I had that train of thought at BMW where I don't want to start tightening these caps down and work the caps down to the camshaft because it's going to put a lot of tension on this hollow camshaft, and I don't want to rock like that. So I thought I was going to be methodical, extra cautious, and I'm like, well, what if I just rotate the camshaft about right here? So you can see my mark for top dead center is positioned right there. And then I can see that almost all the lobes are barely on the lifters, and I can easily just put my cam caps on and suck the camshaft down. So that is our only option on these camshafts. We have to put the cam caps on and slowly tighten those down to compress all the lifters. So on that 575, I position the cam just like this. I set all my cam caps on, put all my nuts on, and let me pop this camshaft off so I don't drop it. And even being as methodical as I was, because I was trying to avoid any damage to the camshaft, I used no power tools and just a small 10mm ratchet, and I tightened down each nut, got the camshaft in. Once it was in location, I rotated it to the top dead center, reassembled my timing belts, did the rest of the job on the car. Well, when I was done and I went to fire the car up, went to crank the engine, it had a gallop. I was new and fresh to the brand, didn't think much of it. Fire the car up, it did not run good at all. We had all kinds of faults. It was clearly not running on all 12 cylinders. Pretty significant issue, and I will show you what ended up happening. Is what we have is these are the two valves removed from that 575. These are two exhaust valves, and I bent two valves because when I had the camshaft in that orientation and I tightened those bolts down, it actually pushed the valve into the top of the piston and bent the valve. So by trying to be methodical, I mean, I thought I was being smart and safe on the camshaft by having it rotated off top dead center. I thought I was being smart by using a small ratcheting wrench and going by hand, not using any power tools. I mean, I didn't feel any resistance. It was so minor. I was shocked that I bent these valves. By trying to go the extra mile and be methodical in what I was doing, I ended up bending valves, had to pull the head off the car, had to completely redo the entire job. It was incredibly embarrassing. It was a very good lesson that I learned. Fortunately, the dealership handled that mistake well, and definitely a learning experience for me, and that is why I'm going through the effort to mention this to you guys now. Because of that instance, I do not do that anymore. I keep the cam on the top dead center mark, and I just have to be real careful walking those cam caps on and getting the cam installed. I'll show you guys here in a second with that. Fun little fact on these two valves, one of them stayed on my toolbox once I bent this for years. I mean, we're talking 7+ years at work. Right there, right in front of my computer, is a daily reminder that just when you think you're being really meticulous and methodical, that can come back and bite you. And, you know, no matter how long you've been doing this and how much experience you think you have, some of the simple things can really bite you. So I had this up as a reminder. I had the one at home also as a reminder. I've always kept these around on my bench and kind of set my mistake in front of me, push myself to get better. And, well, they're reunited again now that they're at home and we're no longer at the dealer. So with that being said, we need to set our cam back in, but I need to get some lube on our journals, and I'll show you just how I get this camshaft in without any issues. All right. So, just set our camshaft in. And there's our mark right there. So I'm going to set it like that for now, just so I can grab a cam cap. So we got our two most rear cam caps here. They're numbered 1 and number 2, so this is what's starting the numbering sequence. And get that started on that stud, like that. Number 2, numbers go upside down. Now, you can see that I don't have a lot of studs sticking up right here. So I don't really even have enough space to get a nut on. And this is where it's a little tricky, because I'm going to get all of our caps here just to kind of keep us honest. It's 6, 5, 4, goes like so. So like, if you notice, this one's marked 1 right here, 2 is on this end of the cap, 3 is actually marked on this end of the cap, and then they moved their engraving, the 4 over here, and then 5. So we have our caps installed, but you can see that there's really not enough threads to get our nuts on, especially considering we have to install washers with it. So the way I overcome that is I actually will install my nuts with no washers first to get everything started, and then as it starts to get pushed down and in, then I'm going to come back and start adding washers. On some of them I may tighten the cap all the way down without a washer at all, and then I come back and replace them. So washers right now are not the necessity, not the worry. We're just trying to get this camshaft in without bending any valves like I did in the past. Don't ever want to do that again. All right. So we have everything just sitting in here. We have no hardware on whatsoever. And we know that if we rotate this cam up there, you can see that it pushed this all the way off. And we have quite a bit down here. So we're going to have to start at the back and start working our way forward. We're back to our business cards, which we used on disassembly, and we're going to set those in place so that way we can be sure that the camshaft's not going to rotate on us. Now, one thing to keep in mind is we're going to be doing the camshaft timing later on, meaning I keep the business cards away from the lobes on the front of the cam where we're going to be doing our measuring, because I want to have these cam caps on tight and I don't want to have to worry about any deflection in the camshaft. Another thing worth mentioning is the engine. We set it on top dead center on cylinder number 1, and that's the position this engine needs to be for these camshafts to line up with their initial assembly marks. So did not mention that, but that is very important. So we're gonna get our nuts on the back started with no washers, and I think if I hold the cam here, I can probably get the second cap started as well. So we got those started, and we're not going to get overly greedy because I want to have this camshaft going in level. I don't want to tighten these all the way down. Basically, my goal is to leave these as loose as I can. We'll back those back up. Just enough to get started until I can get these two nuts started, and then I'll tighten this down until I can get these two nuts started, and then these two nuts, and all the way down. And once I can get all the nuts on, I can work them all in gradually to get the cam where it needs to be. You can see our marks are still lined up. And I'm just going to tighten this down, checking. You can see it moving right there. We're getting close. So I really initially didn't like this method, and that's why I went away from it with that 575, because of the stress that we're putting on the cam. But I am unaware of a different method to get these in without doing it this way. And I can tell you that after my 575 experience, I'm pretty unwilling to deviate at this point. So you can see we got those two nuts just started. And then as we start going down, it's going to push the cam up back here. That's why I don't want those very tight. And just checking our caps. So we don't really have to worry about any piston interference issues over here on this side, because all the pistons are at the halfway point in the cylinders. So even if I did have the camshaft rotated over, like I mentioned on the 575, there'd be no interference issues. And on that car, when I did that, that was bank 1 and it was cylinder 6, which that piston was at top dead center. 1 and 6 are at top dead center on a V12 at the same time, so that's what got me there. We're still lined up on our mark. We're almost. So you can see it's working its way in. Make sure our caps aren't jammed up. And like I mentioned earlier, not even worrying about the washers. We'll come back and get those later. There we go. So we have all the nuts started and the cam is mostly level now, so I can work it in, and we're still lined up with our marks close enough for now. Our business cards are going to basically get rid of any oil gap in between the camshaft and the head, so it's not going to want to rotate, but it still might want to rotate now because it's not tightened all the way down. So we're just going to keep a little bit of pressure on it, and oh, right there. So the camshaft just rotated down to here, and that's from the pressure on the valve springs. I didn't have enough of a grip to hold it, so I need to get the cam back into position. Now this camshaft has no provisions for a wrench. We could try to configure something here on the front with the cam gear. I've seen a lot of camshafts I'm used to have like a hex machined into them, and our camshafts on Ferrari have nothing. However, a 27mm wrench on your cam lobe, and it fits on there just right, where you can see that I can get this cam rotated right there and get my marks lined back up. So we'll just keep that there and tighten down our cam caps, and once it gets tighter, that's where our business cards are going to come into play. That one's pretty much down. Take our wrench off because this cam cap is now tight enough where our business card is going to do the trick and our cam will not rotate. So now I'm going to come back one cam cap at a time, take off my nuts, put on my washers, and get them torqued to spec. And these get torqued to 8.8 Newton meters, which is just essentially hand tight. Now I'm not going to torque the caps that have our business cards because we're going to be loosening and tightening those during the camshaft timing. So we'll leave those for now. And I traditionally come back before I put a valve cover on and retorque all these nuts. Actually a couple times because paranoia. Can never be too sure. But we're going to get them torqued now. So they're at spec. There we go. So you can see it's a little bit tedious, but we've been methodical and get our cams in. It's a bit counterintuitive, like I mentioned, where you kind of have to work the cam in with the cam caps, which is putting that stress in the cam as you're clamping it and pushing it in. However, that method works better than my modified method I tried on that 575. So with that being said, I'm going to continue on, get the exhaust cam installed on this cylinder head, jump over, get the bank 1 head fully assembled, and then we'll come back and there's a little bit to talk about with our front cam seals and cam gears up here at the front of the engine. Not terrible, right? I mean, it's one of those jobs where slow and steady wins the race. Just take your time, ease those camshafts in. Again, make sure your engine's on top dead center, cylinder number 1. Put the camshafts in on their marks, and you should be fine. You won't have any issues to worry about the valves. If you notice, we're cylinder 1, our piston's at top dead center, and you'll see that all the set of lobes on the intake are off of the valve. Same thing for the exhaust, so that is telling me my camshafts are in the compression state over here. On cylinder 4, you can see my lobes are pointing towards each other in the center, and they're not really operating the valves. And since number 4 and number 1 are the only pistons at top dead center, 3 and 2 are at bottom dead center, and everything on bank 2 is at the midpoint, these are really the only 2 cylinders that we need to worry about interference with the valves. Now, one thing to note that is unusual over here is the install mark on the exhaust cam on bank 1 is on the back side of the cam cap, and on the intake it's on the front side, and they're both on the front side on bank 2. Why? Couldn't tell you. Had no clue why that's the way it is. It's stuff like that, honestly, is not super unusual with the brand working on these cars. You find a lot of things that they had did or have done, and there seems to be no apparent rhyme or reason why they did that. So just one of those things to be sure, to make sure you're keeping track of everything. Again, we have the engraved numbers, so this is number 16. They're upright on this side, and I have my 16 there. So I know that my cam cap is on the right direction. There's also no marks on this side of the camshaft, so everything lines up. I do know from memory and doing the jobs that when I'm on top dead center compression, that these cam lobes need to be facing away from each other. That's an easy way for me to quickly visually identify to know that my cams are on top dead center number 1. So with that being said, the heads are on, heads are torqued, and valve train is back into the engine. Alright, so we made some great progress yesterday and today. We got the heads back on, camshafts and valve train all back in, and we're cruising, we're getting back together. And short of the throttles and coolant pipes and our exhaust, we kind of have the engine essentially at the halfway point of a normal timing belt job. Meaning, if you're doing timing belts on one of these 355s and you're replacing your cam seals, you're essentially to the point where I'm at right now. You're going to have your front cam seal plates off, your cam gears off, your belts. And honestly, when I set out to make this video, I actually planned to take this all the way up to the point with getting the timing belts installed onto the engine and tensioned. However, I realized that it's going to be a lot more coherent of a video for those of you using this as a reference. Say if you're doing your own timing belts at home and you're just using this as a bit of a guide. For me, the shift, the timing belt install, everything that I need to talk about, the cam gears, cam seal plates, and tensioning those timing belts to the next video where we're going to be degreeing the camshafts as well. Those topics are very related, and I kind of figure rather than have half of the timing belt job, which would be tensioning the timing belts, included in this video, and then the degreeing the camshafts in their own separate video, it's just going to make more sense to group them together and have them in one video. And I think it's going to just be a better reference, a tool for people down the road that find these videos that have all the information centered around each other where it needs to be. So with that being said, I think this is where we're going to stop at today, and we're going to pick up right where I left off on the next video, getting the timing belts on. Lot to cover on the timing belts, especially with our camshaft gears and the way they index to the camshafts. And I definitely have a lot that I need to cover with you guys on degreeing in the camshafts. It's a little bit of a different technique on these 355s. There's a lot of tooling, a lot of setup, and honestly just a lot to cover with that process. So definitely keep an eye out for the next video because it's going to be another deep, heavy technical video. And it's all going to be centered around our timing belt install, tensioning the timing belts, checking and adjusting our camshaft timing. Alright guys, I hope that was delivered as promised with a really deep technical video. We really had a lot to cover, and I know on the next video with the camshaft timing and degreeing, it is going to be equally as technical, possibly more. Now I know I said it earlier in the video, I want you guys to jump down in the comment section and blow it up. I want to hear what you guys have to say about the work that I'm doing on this car, on this 355. I also want to hear where you guys are from. For myself, here, Auto Technic, we are located in the Seattle, Washington area. So be sure to jump in there. Let me know where you guys are from. I want to see how far this video is making it out there. And honestly, I want to see what all these comments might do to the algorithm. With that being said, I want to thank you for your support. Thanks for watching the video. Greatly appreciate it. And as always, we'll see you on the next one.